Okay, this is the final lesson for Unit 1. This is Lesson 6 in College Algebra. We are still on Unit 1, Intro to Sets of Real Numbers and Set Theory. Today we're going to apply set theory with word problems and use set operations. Several of these examples have been found on the ACT, so this is a good little review for applying set theory. Let's take a look at some practice examples. So we're going to draw a Venn diagram to represent the union and intersection of the given sets. Alex has cats, rabbits, and fish as pets. Becky has cats and dogs. Corey has cats, birds, fish, and turtles. We're going to let A be Alex's pets. We're going to let B be Becky's pets, and we're going to let C be Corey's pets. So what do the three of them have in common? They all have cats, so that goes in the very center. Now, what does Alex have and Corey have that Becky doesn't have? In other words, what pets do they share? Well, it looks as though they have fish together. Now, what pets does Alex have that neither Becky nor Corey has? She has rabbits. So that goes in Alex only. Alex and Becky share no pets that Corey doesn't have. They do share cats, but nothing else that Corey doesn't have. So let's go to Becky. What does Becky have? She has cats and dogs, and it appears as though Corey doesn't have dogs, so Becky is the only one with dogs. And finally, let's look at see what Corey has that Alex and Becky don't have. Well, he has birds and turtles. So this is how we would write this Venn diagram. In the second example, we're going to let X be all of the letters in the word algebra, and Y is going to be all of the letters in the word geometry. Z is all the letters in the word calculus. So we're going to create a triple set Venn diagram, and it's helpful to define them then as X, that's algebra, Y is geometry, and Z is calculus. First, let's see what they have in common. It appears as though none of the letters are common to all three sets. So now let's go to algebra. Algebra has a GER, and so does geometry. So they share a GER in common. Okay, algebra also has an AL, and so does calculus. So AL is shared with algebra and calculus. But algebra has a B that geometry and calculus doesn't have. So let me just make sure that I have spelled algebra. A-L-G-E-B-R-A. Okay, so I have all the letters of algebra covered. Now let's go to the word geometry. Okay, I've already found what geometry has in common with algebra. Let's see what they have in common with calculus. It doesn't appear as though calculus and geometry share letters. So I'm going to finish the word geometry inside the Y bubble. So I have G-E-O-M-E-T-R-Y. Okay, so in the set Y, but not in the other two sets, is O, M, T, and Y. And then finally, let's go to calculus. Again, we already determined that calculus shares no letters with geometry, AL with algebra, so what I'm left with is C, U, and S. So this would be the Venn diagram for the given sets. All right, let's take a look at some application. We're going to respond to the following situation involving sets. Number 3 reads, find two sets A and B such that A union B is equal to 1, 2, 3, 4, and 5, and A intersect B is equal to 2. In this situation, answers can vary as long as the intersection between A and B is the number 2. So 2 can be the only thing that goes in between, but it doesn't tell me what elements need to be in A, what elements need to be in B. So we can define A as 1, 3, and B as 4, 5. All right, let's take a look at the next problem. Number 4 reads, let M equal the set of x such that 3x, such that 3 is being multiplied by x, and x is an element of the integers. And then we're going to define n as the set of all x such that 4 is being multiplied by x, and x is an element of integers. All right, so in other words, m is a multiples of 3. N are multiples of 4. How would you describe the intersection between these two unions? Well, we have to think, okay, what does M and N have in common? They have to be, what they have in common has to be divisible both by 3 and 4. In other words, they need to be multiples of both 3 and 4. Well, another way of saying that is they're multiples of 12. So, namely, the set 12, 24, 36, etc. Okay, let's take a look at number 5. Set X has 10 elements. Set Y has 15 elements. The intersection of X and Y has 5 elements. How many elements are in the union of X and Y? So let's create a Venn diagram. Let the left one be X, the right one be Y. What do we know about the intersection? X and Y intersected has 5 elements. X total has 10 elements, but 5 are already accounted for, so there's 5 left over. 5 plus 5 is 10, and that's how many elements X has. Set Y has 15 elements, but 5 are already accounted for. So what's left over is 10. 5 plus 10 is 15 elements. So the elements that they have in common, X union Y, is 20. So X union Y has 20 elements. Now we're going to look at number 6. We're going to find two sets A and B such that the union of A and B is 1, 2, 3, 4, and 5, and that the intersection is null set. Now, in this case, answers can vary as long as the intersection of A and B shares no elements. So here we have A, here we have B, and we can let A be 1, 3, and 5, and B be 2 and 4, and then they would share no elements in common. Finally, we're going to identify the following statements as true or false and use a Venn diagram or give a counterexample to justify any false answers. So we're going to take a look at number 1. The intersection of two sets is always a subset of their union. All right, this is true. So if I have two sets, A and B, Even if the intersection is a null set, that would still be a subset of A union B. Whatever is in the middle of the two sets, okay, we have A, B, C, okay, the intersection B would be a subset of A union B. So it is always true that A intersect B is a subset of A union B. Two sets that contain no elements in common are disjoint sets. Okay, this is also true. Okay, so no elements in common means that they're disjoint. The intersection of the set of even numbers and the set of prime numbers is the empty set. Well, let's take a look at even numbers. This would be 2, 4, 6, 8, etc. The set of prime numbers starts with 2, 3, 5, 7, 11, etc. They do indeed share one element in common, namely 2. So this would be false. The set 2 is the intersection of prime numbers and even numbers. At the end of this section of notes, I have provided for you a little cheat sheet, okay, which shows all of the possibilities for uniting or intersecting sets. So this is a nice little reference sheet to take a look at A intersect B, A union B, A not, A intersect B not, A not intersect B, A union B not, A not union B, A not union B not, which is equal to the intersection of A and B not, and then finally A not intersect B not, which is A union B not. So this might be a nice little reference sheet as you complete any of your homework assignments. Okay, this is the end of Unit 1 on sets, set theory, and the introduction to college algebra.